Welcome to another video. Let's solve for the value of x in this problem. So the first thing we're going to do here, given this nice problem, is we are going to take the x root of both sides. So we have this as x raised to power 2, all raised to power of 1 divided by x equals to bracket 5 minus root 24 raised to power of x and all raised to power of 1 divided by x. So if x cancel x in this, so this one becomes, by applying the law of exponent, so we are going to interchange the power, which is 1 over x raised to power of 2 equals to, the entire of this becomes 5 minus root 24. And again, I want to segregate 2 from this side. So by taking the square root of both sides, we have x raised to power of 1 over x raised to power 2 equals to plus or minus the square root of 5 minus root 24. And again, so this square will cancel square root, and here we are left with x raised to power 1 over x equals to plus or minus. But I want to do something here. So if you have the root of, so we know that this 24 we have here, so we can break it down into the product of 4 and 6. So by taking the square root of this, so 4 is a perfect square and it becomes 2 root 6. So replacing it here, we have 5 minus 2 root 6. And again, we have x raised to power 1 over x equals to plus or minus the square root of, so if I break this 5 into 3 plus 2 minus 2 root, for the 6 we have it as 2 multiplied by 3 or 3 multiplied by 2 anyhow. So the next thing is we have x raised to power x equals to plus or minus the square root of, so we know that these 3 can be written as, you have root 3 and I manipulate it to be having square, so plus y for this we have root 2y to be having square, so we have this as minus 2, separation of this becomes 2 root 2 and root 3. And again, if you borrow this knowledge of a squared plus b squared minus 2ab, so we know this is just like a minus b all raised to the power of 2. Suppose I have my a to be root 3 and b to be root 2. So just try to replace everything. We have x raised to the power 1 over x equals to plus or minus the square root of, so we have this as root 3 minus root 2 all raised to the power of 2. So on getting this and this will cancelled, and we have x raised to the power 1 over x equals to plus or minus root 3 minus root 2. And this is where we are going. So since this one collects both positive and the negative, so we are going to deal with the symbol separately. So for the positive symbol, we have x raised to the power 1 over x equals to root 3 minus root 2. Remember that our aim is to obtain the value of x. So this, we are going to introduce ln to both sides. So the reason is to take the power down. So I will have ln of root 3 minus root 2. And if 1 over x comes down according to the rules, we have 1 over x ln of x equals to ln bracket of root 3 minus root 2. Then we know that this 1 over x, so it can also be written as x raised to the power minus 1. So we have this as ln x equals to ln of root 3 minus root 2. So the next thing I'm going to do here is, if I try to replace this x raised to the power of minus 1 with introducing exponential and ln to it. So we have e raised to the power of ln x raised to the power minus 1, because this e and ln, they are inverse, they cancel each other. So, and we still have our x raised to the power minus 1. So this equals to ln of root 3 minus root 2. So suppose I let ln of x start. So we have this as ln x exponential minus ln x. So I take the negative 1 back to the ln. So that's what we have there. So and we have this as ln of root 3 minus root 2. So, the power of this exponent is having negative. So if I try to introduce negative throughout, so we have negative ln x e raised to the power of minus ln x equals to negative ln of root 3 minus root 2. So for this right hand side, which is minus ln of root 3 minus root 2, I want to do something there. If you try to take this negative to the top, so we have this as ln of root 3 minus root 2 raised to the power minus 1. And this one is just like 1 over root 3 minus root 2. So the entire of this one becomes ln of root 3 plus root 2. So what I did here is, you can just pause this video and try to rationalize it. So if you rationalize, so we are going to get root 3 plus root 2. I don't want to show it, so but that's what I applied there. And here is minus ln x exponential of minus ln x. So if I try to introduce w to both sides, which is a Lambert, so we are going to have minus ln x equals to w of ln bracket root 3 plus root 2. And if I take negative 2 out of this, so we have ln x equals to minus w of ln of root 3 plus root 2. So since I'm looking for x and we have ln x, so what can make ln cancelled in this is by introducing exponential to both sides. And we have e ln x equals to e minus w of ln bracket of root 3 plus root 2. So we thereby have our x to be equals to exponential of minus omega of ln of root 3 plus root 2. And this gives us the first solution for the value of x when positive. And let's say the second solution. So for the negative values, we have x raised to 1 over x equals to minus bracket root 3 minus root 2. So by applying the same approach, we have x raised to minus 1 ln x equals to ln of minus. So we have root 3 minus root 2 bracket. So for this one, by introducing the same approach for the first one as the first one, so we have this as ln x e raised to the power of minus ln x. So just as we did previously, so we have this as negative ln of negative 1 plus ln of root 3 minus root 2. So what I did here is just like I separate negative from root 3 minus root 2. Following this, suppose this negative is a and all these are b. So if you have the rule of indices that says ln of a dot b, so it becomes ln a plus ln b. And that was what I applied. So just like separations. And we know that this minus 1 that we have in ln, so it follows this exponential of I pi equals to minus 1. So we just try to replace this ln minus 1 with exponential I pi. And here we have ln x exponential of minus ln x equals to ln bracket of exponential I pi. And so I'm not going to limit myself here because for every n number, so we can have as many as n. So we're going to have 2n plus 1 to this. So, and plus ln of root 3 minus root 2. So where the value of the n is a member of an integer, and for all n, so n is a member of an integer. So by proceeding with this, just introduce the negative to both sides. So we have ln x e raised to the power of minus ln x equals to, so exponential cancel ln with this, and we have I pi bracket 2n plus 1 plus ln of root 3 minus root 2. So the introduction of negative to this, and we are going to have this as minus ln x exponential of minus ln x equals to, by introducing negative to this side, so and we try to rationalize it. So we have this as ln of root 3 plus root 2. Then, so the negative will now affect minus I pi bracket 2n plus 1. So therefore, we take the omega of both sides, so and thereby we have the result of x to be x equals to a exponential of minus omega of ln of root 3 plus root 2 minus I bracket 2n plus 1 all bracket. And if you like, we can introduce a k to the base of omega, as omega k can be any number. So that's how to solve this problem. Thanks for watching, and don't forget any steps to miss out. Subscribe to this channel and like this video. I will see you in the next class. Bye bye.